Problem 5. We're still going to prove like this top triangle up here, right? This triangle must be congruent to this triangle. That's what they're asking there. But this is where it gets interesting. These are the fun proofs because there is very little given information, and it's not even a congruence fact. It's just some property in geometry, and they're going to tell me C is a midpoint. And it's a midpoint of two things. It's a midpoint of AD. So this entire thing, CD is doing something to it. I'm sorry, the midpoint C is doing something to that entire side AD. And it's doing what midpoints do. They make congruent sides. That midpoint is going to split it up into two equal pieces. So I know to the left, this piece here has got to be congruent to what's on the other side of that blue point, this side there. And not only is it, a midpoint of AD, it's also, right, and that means in addition to, it's also a midpoint of side BE, this side here. That blue point is doing what midpoints do. It's splitting it into two equal parts. And I can tell the green pieces are different sizes than the red. That's why I'm using different numbers of tick marks or congruence marks. So from that one fact, I get two side facts. I'll have to write it up and cite definition of midpoint, but I've got side and side. And now I'm in that mode of, okay, I've used all my givens, all right? I've done that. I got to keep an eye for any free facts that might be there. There's no reflexive, but I do see vertical angles in this problem. I've got that crisscross right there. And here and here. Those angles. That angle C is congruent to angle C. We can't do that. That's a no-no. That looks like the reflexive property. We have to be diligent and use the three-letter name. We have to be precise. So A to C to B. This angle is angle ACB. It gets C in the middle. And then we come down, and we can see that this angle here, this angle right there, is angle D to C to E. That is angle DCE. And that will be vertical angles, right? Vertical angles. And that's how I'm going to get my angle. And that angle is included, right? It's an included angle. It's between my two congruent sides. That's how I know this is a side angle side. It will work. So I'm ready to write up my proof now. And this one's only got one given, namely that C is a midpoint of side or segment AD and segment BE. Well, how did I know that? That was a given. While that isn't a side fact in itself, it will tell me some information. It's going to tell me, namely, that this side here, AC, must be congruent to this side over here, CD. So that's going to be my second statement, that AC is congruent to CD. And how do I know that? Well, that's the definition of a midpoint. That's what allows me to say that, right? That midpoint, right? That's what lets me say it. The next thing I'm allowed to say is that this side here, BC, right, that side there, must be congruent to this side here, CE. And it's for the same reason, all right? It's BC must be congruent to side CE, and it's literally because C is a midpoint. That's the definition of a midpoint. Right? That BE and midpoint are what tell me that. So this is a side fact. This is a side fact. I'm ready to get to my vertical angles right there. I'm ready to say 4, angle ACB. ACB. It's so easy when you take accurate notes because it's just copying at that point. You've done the work. Those angles are congruent because they are vertical angles. And you got to write it out. No shorthand. And that's an angle fact. And I know it looks like SSA, but according to our diagram, this is a side angle side proof, because that angle is in between side angle side. It's included between our two congruent sides. So we got to write it up that way. 5. Triangle ABC must be congruent to triangle DEC. Well, that's because of the side angle side postulate.